Greeting you, blessed morning class. In our last encounter, we're done discussing about what is a sequence, and also it's time today we have a new set of topics to tackle, which is interactive mathematical language and symbol, as far as I remember. And if I'm not mistaken, I have assigned two groups to discuss the two components of it, right? For the first group, I asked to report the basic concept of mathematics and elementary logic for the second group. And where is the first group? By the way, who is the presenter for the first group?
Me, Mr. Caparoso, Mr. Pantinople, and Mr. Senyas, ma'am.
Are you settled now?
Yes, ma'am. We're more than ready.
Good to hear though. Okay, proceed.
Pleasant morning to everyone, especially to you, ma'am. So let me introduce first myself. So I'm John Glata, and my reporting partners are Mr. Caparoso, Mr. Senyas, and lastly, Mr. Pantinople. So we are the first group presentators. The topic that was given to us is the basic concept of mathematics, and we will lecture you on it. To discuss the first element of the basic concept of mathematics, here comes Mr. Caparoso. Take it away, girl.
The first element is the set. Basically, set refers to a collection of well-defined objects that contains no duplicates. The objects in the set are called the elements of a set, may be anything under discussion. To describe a set, we use braces and use capital letters to represent it. For example, the bank account in a bank, or the set of natural numbers n is equal to open braces 1, 2, 3, and so on, close braces. The integers number z is equal to open braces, so on, negative 3, negative 2, negative 1, 0, 1, 2, 3. The method in describing sets, the roster method, is done by listing down each element separated by comma and fully enclosed by braces. In doing the roster method, consider the order of the elements does not matter. The elements are only listed once, thus listing an element more than once does not alter this set. For example, A is equal to open braces, point, line, plane, close braces, point, A space, cross, A. The rule of description method is done by describing a set in terms of properties which is satisfied by the elements of the set and by those elements only. One way of doing the rule method is by the set builder's notation. It is in the form of A is equal to open X satisfy a certain properties, which as read is A is the set of all objects X, such as X satisfy a certain property. Example is D is the set of all objects X, such as X is a city in the region 2. Classifications of set. Number 1, universal set is a subset universal. Set contains all the elements in a particular context or condition. The universal set is usually represented as set U. For example, when you came discussing the English alphabet, the universal set will be the letters of the English alphabet. Other letters or symbols are not included. On the other hand, a subset is a set whose elements are also element of another set. Number 2, finite set and infinite set. A finite set is a set whose elements are definite or can be counted. The the table is the example of a finite set, while infinite set is which is not finite or its elements are impossible to exhaust. Set F is an example of an infinite set. Number 3, a null set or empty set is a set with no elements. It is denoted by braces or not equal to 0. Mr. Clara, can you share the class what's the second element?
Gotcha, sis. So the second element is the relation. So what is a relation? So basically, a relation is not the relationship you know with someone, okay? So the relation in math pertains to a set or collection of ordered pairs. An ordered pair has two components, which are the x coordinates and the y coordinates. In this example, we have open and close parenthesis x and y, open and close parenthesis 5 and negative 2, and open parenthesis Ben and back. So in this example, 5, x, 5, and Ben are what we call the x coordinates, while the y, negative 2, and the bag are the x, y coordinates. Relations can be presented through the following methods. First is the set notation. So example is inside braces we have open and close parenthesis 1 and 2, open and close parenthesis 2 and 4, open close parenthesis 3 and 6, and lastly open and close parenthesis 4 and 8. The second is the tabular form. So in this example, we have the x coordinates, which are the A, B, C, and D, while the y coordinates we have apple, the ball, cat, and the dog. Lastly is the mapping diagram. So in this example, we have the x coordinates, which are the Alaminos, Batac, Candon, Dagupan, Lawag, San Carlos, San Fernando, Urdaneta, and lastly the Bican. And for the y coordinates, we have the Ilocos Norte, Ilocos Sur, La Union, and Pangasinan, which are Alaminos and Dagupan. San Carlos and Urdaneta are located in Pangasinan. Batac and Lawag, on the other hand, located in the Ilocos Norte, and Candon and Vigan located in Ilocos Sur, and lastly, the San Fernando in La Union. The set of all x coordinates, or the collection of all the first values in the ordered pairs, is what we call the domain, while the set of all y coordinates, or the second or a collection of all second values in the ordered pairs, are what we call the range. To explain to you the third element, here comes Miss Nasenias.
Thanks, girl! The third element is a function. So it refers to a rule that pairs each element in one set. Called the domain, the exact one element as a second cell called the range. Take note that as functions are relations but not other way around. Functions strictly follow the rule that each member of its domains is mapped to only one member of its range. Example number 1. Close and open braces 1 and 2, close and open braces 3 and 6, close and open braces 4 and 6. Notice that each of the first value is paired to a unique and the second value. This relation is called one-to-one and it is a function. Function can also be a representative by an equation. A function is usually denoted by f of x is the real of x squared, or the function of x. The domain of the function are the possible values of x. Example, determine the domain of the given function. Number 1, f of x is equals to x plus 3. The domain of the function is the set of all real number since all real. The second, f of x is equals to x times 2. The domain of the function is the set of all real numbers since all real numbers can be substituted to x and will be give a real number. And the last element will be tackled by Mr. Pantanopoulos, and boy, it's your time to shine now.
Thank you, girl. So, the last element is the binary operations. This element refers to a set is a calculation involving two elements of the set to produce another element of the set. Other binary operations can be defined in any way provided that it stays consistent on a given set. It means that a binary operation in a situation may be defined differently in another situation. For assistance, let the binary operation be defined as the ordinary addition plus in RA 32 minus 17 equals 32 plus 32 plus open parenthesis minus 17 close parenthesis equals 15b open parenthesis 5 6 close parenthesis minus 2 equals open parenthesis 5 plus 6 close parenthesis minus 2 equals 11 plus open parenthesis, minus 2, close parenthesis, equals 9. Other than addition, the common binary operation used are subtraction, multiplication, and division, the four basic operations in mathematics. Binary operation can also be defined this way. Let the binary operation be defined as AB equals A plus 2. B, solve the following. A, 3 equals 3 plus 2, close open parenthesis 4, close parenthesis, equals 3 plus 8 equals 11. B, 2, close open parenthesis, minus 2, 5, close parenthesis, minus 2, close, minus 2 plus 2, open parenthesis, 5, close parenthesis, equals 2 plus 2, open parenthesis, 8, close parenthesis, equals 18. A binary operation on a set is commutative if and only if AB equals BA for all the elements of the given set. The ordinary addition and multiplication are commutative while division and subtraction are not. A binary operation on a set is associative if open parenthesis AB close parenthesis C equals A open parenthesis B C close parenthesis for also the elements of the given set, and that concludes our decision about the basic concept of mathematics. We hope you grasp something. Thank you for listening.
On next, second group.
Hello guys, even though we may be the last, we're not the least. Just kidding. I'm Shalome Montezo and this is my Kamantua, my co-presenter. Well, introduce you to the topic that was handed to us, namely elementary logic. So, what is elementary logic? Elementary logic enables us to evaluate the validity of argumentation both inside and outside of mathematics. Proposition is a declarative statement of logic that may express an idea which can be true or false, but not both. Expressed by the symbols expressed by symbols big letter PQR or small pqr. Types of propositions. 1. Simple means a single idea statement. 2. Compounds conveys two or more ideas. To give you an examples of logic connectives and symbols, and also the qualifier I present to you, Miss Mantua. Bring it on, girl.
Thanks, girl. So those are the logic, connectives, and symbols. Statement. Not P, connective, not. Symbolic form, negative P. Types of statement, negation. P and Q, connective, and symbolic form, P and Q. Types of statement, conjunction. P or Q, connective, or symbolic form, P or Q, disjunction. If P then Q, connective, P then symbolic form, P conditional Q. Types of statement is conditional. P, F, and only F, Q. Connective, F and only F. Symbolic form, P by conditional Q. Types of statement by conditional. There are two types of quantifier, namely universal quantifier and extension quantifier. So universal quantifier refers for all and everybody denoted by. On the other hand, extension quantifier there exists denoted by. To tackle the converse, inverse, and contrapositive and of conditional, Miss Monteso, back to you, girl.
So, these are the converse, inverse, and contraposition. The converse of P then Q is Q then Q. The inverse of P then Q is negation P then negation Q. The contraposition of P then Q is negation Q then negation P. Miss Mantua, can you give an example of logic?
Girl, I got you. Example of logic. Write the following in symbolic from using PQR statement and the symbol. P equals the sun is shining. Q it is raining. R the ground is wet. Number 1. If it is raining, then the sun is not shining. Answer Q contrapositive P.
And that's the end of our discussion about elementary logic. Have a blessed morning, everyone, and thank you for listening.
Wow, I was absolutely astounded by your presentation. I was astonished at how much work everyone to put forth. It was indescribable sensation. Good work, everyone, and it's already time. So, thanks for coming to my class, and I will see you at our next meeting.